Today we're going to be talking about the slope formula, and then we're also going to be talking about the slope-intercept form that you learned last year. Let's see, y equals m times x plus b. We've talked about so far that the rate of change, okay, or slope is, we can call this rate of change, in other words, slope. We use the variable m or the representation. We can say that is the change in y over the change in x. Here is our symbol, the delta symbol, change in y over change in x. Change in the dependent variable, which is still our y-axis, over the change in the independent variable, which is our x-axis. We can call it the vertical change, up and down. We can over the horizontal change, right and left. We can call it the rise, which is our vertical change, over run, which is our horizontal change. Or if you look here at our y-axis, it's descriptor of the speed of a consistent skunk is going to be in distance. So that's going to be our rise. So it's the change in miles. And here is our horizontal axis, time in hours, over our x. So we've got lots and lots of ways that we can call slope, just like you have lots of ways that different people call on you. At least in my house, and sometimes what we call each other is not what we need to be calling each other, right? Okay, so to start out, to find the slope of the graph, Aiden counted the rise to be 6. Okay, so we can see that our y-axis is counting by 2s, and our x-axis is counting by 2s also. So we went up 2, 4, 6. That's our rise. Okay, and that's how he came up with this. Over our run, okay, in our run, we're also counting by 2s, 2, 4, 6, 8. And that's how we've got our, let's see, our run to have been 8. Okay, so let's talk about then, using the ordered pairs, how else could Aiden have found the rise to be 6? Well, we know that the rise has to do with y, so the change in y. So we could have said that we've got 16 here, take away 10. And we could have said that that equals 6. So that's how we could have got to find rise. Okay? And then using the order pairs, how else could Aiden have found run to be 8? Okay, so that's going to be changing our x. This is our y value. So then we could have changed in x. We could have said our x is going to be as 16 as well. And we're going to take away 8. And that would have given us 8. Well, we have a formula, guys. And this is a formula that we're going to be using a whole lot. We can describe the slope as the following ratios. Ratios, rise over run, change in y over change in x. But we have a slope formula. Our formula for slope is on our math chart, and it's really at the very top under linear equations, which means it's very important. M represents our slope, and we write it as y2, take away y1, over x2, take away x1. Okay, have you heard of that before? It's not any different than what you see over here. We've got our rise over our run, rise over our run. Okay, so we'll be using tables, and we'll be using graphs to determine what our rise is, or what our slope or rate of change is. Okay, so our formula is going to be m equals y2, take away y1, over x2, take away x1. Guys, these aren't exponents. Okay, so here would be our rise here at the bottom. That's going to be our run, our x values. So we can use any set of points that we want to use. Okay, so I'm going to go ahead and just call this, and I'm going to call this y2 and y1. So this would have to be x2 and x1. Okay, so we're going to say 5 and 5/10. Change means subtraction, so let's make sure that we've got our subtraction. 5 over 1, take away 0, which is going to give us 5/10 over 1, and 5/10 over 1 gives us 5/10. We can put the 0 in front of it if we want to. There it is. Okay, slope is 5/10. Number 2. Okay, so give you a second to put that down. I don't know if I'll put this up there. Okay, so come on here. Oh. Okay, so again, here we have our change. There you go. Okay, so we've got our change in y. We've got our change in x. This time, let's take another set of points. And so let's go ahead and use this point, and let's use that one. Okay, so our slope formula, slope is y2, take away y1, equals x2, take away x1. Okay, I'm gonna go backwards this time, so I think that I'll just call this one y2 and y1, x2 and x1. Okay, so we'll take our 62, and I'm going to take away 110 over, keep the same pattern, 8, take away 14. Okay, so we know that we've got a negative, and let's see, what would that be? If that was 110, take away 60, that would be 42 different, so it looks like it's going to be 38. You can correct me if I'm wrong. Negative 38, because I took out more than what I had, and then negative 6. Negative over negative gives us a positive, doesn't it? Okay, so we're going to have a positive. I'm going to reduce that by 2 over 2, and that would be 19 over 3. So our slope is 19 over 3. Okay. Same thing here. We're going to identify these 2 points on our graph. Okay, so we're going to go ahead and find the x and the y values. This point, x did not move right or left, so it stayed 0. And then we moved up to 80. By the way, that's our y-intercept, isn't it? Because here is our axis, and the slope intercepts there at 80, so this is going to be our y-intercept. And you guys wrote it as B last year, so 80 would be our y-intercept. We'll be getting that today as well. Okay, our second point, the x value is 5, and the y value is 50. Okay, so when we use our formula then, y, let's see, our slope equals y2, take away y1, over x2, take away x1. Okay, so let's just put in our numbers then, and we'll call this, really doesn't matter how you, let's see, let's get this skinny now. Okay, so we're going to call this y2, y1, so this has to be x2, x1. Okay, so we've got 80, take away 50, over 5, take away, no, I did that backwards, didn't I? Made a mistake. Okay, so I have to be careful, make sure that I keep the same pattern, 0, take away 5. So that's going to give us 30 over negative 5, isn't it? So we know that's going to be a negative. I'm going to divide that by 6 over 6. So that would give us a negative 5. Wait a minute, I can't do that, can I? Okay, let's back that up, sorry. Okay, we're going to reduce that by a 5 over 5, and so that's going to give us negative 6 over 1. So our slope is negative 6. But we want to remember that it still is a ratio. You're going to need that for rise over 1. Okay, guys, this is going to be the end of video 1, day 6. You're going to go on to video 2, day 6. Okay, I'll stop this. Thank you.